Dear students, in this video we are going to discuss about working of NPN transistor in active region. That means in the previous video we have discussed there are four region of operation, okay, based on the different biasing for the two junctions present in the transistor. So especially we are going to discuss about the active region. So the transistor will act as an amplifier. Okay, so let us start how the NPN transistor is working in active region. So as we discussed in the previous video, the active region means the first junction should be forward biased and the second junction to be reverse biased. The first junction is nothing but emitter based junction is forward biased and the collector based junction is reverse biased. So according to this condition, now I am going to give the connection for the NPN transistor and we are going to discuss how it is working. Okay, so first let me draw the NPN transistor. So it consists of the three terminals. Okay, this is the three terminals. So this is three terminals I mentioned here. So this terminal here NPN. So towards N it should be the arrow mark should be there. So this is emitter, okay, and this is base and this is collector. So by seeing this diagram you can understand. Now you see the first junction here I will write EB junction should be forward biased. This is the condition for active region. EB junction is forward biased, okay, J1, and the collector base junction should be reverse biased. Reverse biased. So accordingly, let me give the connection. So this is emitter, this is base. So this should be forward biased. So this is the NPN transistor. So N and P. Okay, for this I have to give the forward biasing. So forward biasing means N type should be connected to negative terminal of the battery and P type should be connected to positive terminal of the battery. So that this EB junction is forward biased. EB junction is forward biased. Next, the collector base junction should be reverse biased. So now this is the base and this is the collector. Okay, so how the connection should be given? It is reverse biased. So P type should be connected to negative terminal of the battery and the N type should be connected to positive terminal of the battery. So this CB, that collector base junction, is reverse biased. So the first junction is forward biased and the second junction is reverse biased. Okay, so according to the condition we have given the biasing, right? And then how this is the connection part. Next we are going to discuss how it is going to work. Okay, what is the working part of the NPN transistor? So let me draw one more diagram for understanding. By means of charge carriers I am going to explain. Okay, so first part is the emitter part. It occupies the moderate size in the transistor. So this is N type, and the second one will be the thin region, that is the base, here P, and the third one occupies large space. Why? Because it is the collector. So now this is the J1, right, and this is the J2. J1 is connected to the forward biasing. So N type is connected to negative terminal and the P type is connected to the positive terminal, right? And the next one will be P should reverse biasing. For junction 2 it is reverse biasing. So P should be connected to negative terminal and N should be connected to positive terminal of the battery. So this is what we have given the connection. Okay, so next, in case of this N type, electrons are the majority charge carriers. So moreover the emitter is heavily doped. Okay, more number of charge carriers will be there in case of this emitter. In N type, more number of charge carriers are there. Why? Because it is heavily doped, right? Next, what is the second one? Base. Base is the P type and it is very lightly doped. So it consists of very small number of charge carriers, that too holes. Okay, so holes. very less number of holes will be present in this case. Why? Because it is lightly doped and moreover it is very thin in size, so that it has very less number of holes. And next we are coming to the collector. It is moderately doped. Okay, it is moderately doped. So comparatively with the emitter, it contains less number of charge carriers comparatively with N, that is emitter. Okay, so this is the part of the collector, right? So this is what the charge carriers. So this is what I mentioned as the charge carriers, how it will be present in this NPN transistor. Okay, so the next part is how it will be connected. This is the forward biasing. So this is the negative terminal and this is the positive terminal, and here this is negative and this is positive. Okay, first let us discuss the first junction. Already we know that the first junction will be, here I can draw, this is the depletion region, right? Depletion region. So this depletion region will be narrow, okay, but here the depletion region will be wider. It should be wider comparatively with this. So the junction J2 will have the wider depletion region. Okay, so now listen. So here once it is forward biased, when the junctions are forward biased, this is negative charge and the electron is also having negative charge. So due to this like charges, it gets more repulsive force, so that the electrons will cross across the junction. The electrons will cross across the junction, but here more number of electrons are there. But P, that is the, what is mean by P here? P is the holes. It consists of majority charge carriers of the holes, but it is very lightly doped. So the number of holes present in this region will be very less in number. So what will happen? 2%, very minimum amount of the electron recombine with the hole. 2% of the electron only recombine with the hole, but a very large number of electrons are present here. So due to this recombination of electron and hole, the base current will be produced. The base current will be produced. So the base current is represented by IB, base current. Okay, now in this case of emitter, you see the electron movement in this direction due to the repulsive force. So the current will be opposite to the electron movement. So here emitter current will be in this direction, right? Here due to the recombination of electron and hole, the base current will be constituted. Okay, and then so when the electrons, when this charge carriers move across the junction, that condition already we know that. So the forward voltage, okay, the forward biasing voltage, okay, should be greater than the barrier potential. How much barrier potential this junction is having? Especially for silicon, the barrier potential will be around 0.7 volt. For germanium, it is around 0.3 volt. Okay, for germanium transistor, the barrier potential is 0.3. So when we give the forward biasing greater than 0.3 volt, then the electrons will cross across the junction. Okay, the same thing for silicon, it should be around 0.7. So the forward biasing crosses 0.7 for silicon transistor, then that means the movement of electrons over the junction will takes place. And then after reaching this base, it contains very less number of holes due to the thin size and then doping level. Only 2% of this charge carrier will recombine, so that it constitutes the base current, and the remaining, you see here in case of emitter, large number of electrons are there, that is large concentration of electrons. But when we compare it to that means collector, here very less number. Okay, so here higher concentration, here lower concentration. So this electrons will move due to the diffusion, from higher concentration to lower concentration. This electrons will cross across this junction J2, cross across this junction J2. So this, because of this diffusion, the collector that means the collector part constitutes the current, which is represented by collector current, So this collector, the electrons are moving in this direction, so the collector current should be opposite to that. So now due to the diffusion part, here higher concentration, here lower concentration, so that the electrons will through the base diffuse through the base, and then it reaches this collector part. So this collector current is also known as injector current. injected current. Injected current. Okay, why it is called injected current? Why? Because the electrons are injected by the emitter. The electrons are injected by the emitter. That's what it is it is known as injector current. Collector current is also known as injector current. So in this way the current flow will takes place in this NPN transistor. Here it produces large current, so it will act as the amplifier. Okay, so this is the function working principle of NPN transistor in active region. Okay, so let us discuss one by one again the same steps. So first you have to draw the diagram and then you have to explain. What is the first point? Depends upon the active region, we have to give the connection. So the first connection, first one is EB junction to be forward biased. That is the first part, forward biased. And then collector base junction is reverse biased. This is reverse biased, first point. And then as we know well, the depletion region of this that is EB junction is having narrow depletion region, narrow depletion region. And then collector base junction is having wider depletion region, wider depletion region. Okay, and then here we are talking about a NPN transistor. So emitter provides large number of electrons, large number of electrons. Why? Because it is heavily doped, it is heavily doped. Okay, and then base, here base is the very small and thin and lightly doped, thin and lightly doped. So it consists very less number of holes, very less number of holes. And then what about collector? Collector consists of moderate number of electrons, moderate number of electrons. Why? Because it is less doped or moderately doped, moderately doped. Okay, so now here we have given for emitter and base we have given the forward biasing, so that the electrons gains energy, it crosses the forward, that means it crosses the junction. Okay, so here for silicon the forward biasing, that means the potential barrier is 0.7 volt. So the forward biasing should be greater than 0.7 so that the electrons will move across the junction. Especially for germanium it should be 0.3 volt. Okay, and then the flow of electron will takes place. So the IE, that is electron emitter current will be produced in this case, and then it reaches the base. Here the base is very thin and lightly doped, so recombination takes place only for 2% of the electrons, and the remaining electrons will be injected to the collector, so that very high amount of collector current will be initiated. So this is for emitter and this is for base and this is for the collector. Okay, generally according to the Kirchhoff's law, according to the Kirchhoff's law, IE should be equal to IB plus IC, IB plus IC. As we discussed earlier, the IB will be very much lesser than, that means IB is the current due to the base will be very less enough, so that it should be almost considered it as equal to 0. So if IB becomes 0, we can write IE is equal to IC. IE is equal to IC. Okay, so this is what happened in the case of the NPN transistor in the active region. And moreover, we can just discuss the VI characteristics of that voltage. Okay, so VI characteristics, actually two biasing, so that we will get it two graphs. So the first graph voltage is voltage EB. What is this? voltage applied across E and B, emitter and base, first junction, and this is for IE, okay, emitter current. So this is like a normal input diode, how we will get forward biasing. So this is for forward biasing, right? The first junction is forward biased. So we will get the graph as usual. Okay, once it crossed the threshold voltage, then the current will be increased rapidly. Okay, and the next one, that means for the second junction, so the second junction will be VCB, voltage across the collector and base. This is the reverse biasing. So in this case, actually here the current should be mentioned as IC. Okay, so the current will be increased at first, but once it reached the IE value, then it will be saturated enough. So this is the IE. This is the IE. So IE is always equal to IC. IE is always equal to IC. So these are the two characteristic, that is voltage versus current characteristics for two junctions, forward and reverse biasing junction. Okay, so I hope you understand how the NPN transistor is working. Okay, so please go through this. If you have any doubt, you can ask in the comment box. So thank you everyone.